Okay, so we completed till over here this meter base problem, isn't it? Okay, so let me start with some special kind of a question I want to do for a meter base. Got it? Let us take up that question. Right or not? It says that let's suppose 1 minute. Okay, so look over it. It says that let's suppose if I took one resistor, then another resistor. Okay, and I connected them with a meter base. Got it? And then this whole system was connected with a battery. Now there is a twist in this question. The twist which I wanted to bring, that let's suppose this is my resistor. So this is a resistor R1, this is a resistor R2. Okay, and at point C I added one galvanometer, and this galvanometer is connected with a jockey, as you know that. Okay, let me draw like this. And it's pointing at this point J over here. Got it? There are 2 points E and F. Got it? Yeah, let's call it as D, not J. Okay, so question is, the point is very simple, that D is my balance point. Got it? D is my which point? It's a balance point. Question is, find the direction of current. Got it? If or in galvanometer, if jockey is touched at at 2 points, first point E and second time at F. Do it. What it is saying? That my D is my balance point. Got it or not? Then you have to find the direction of current in the galvanometer if the jockey is going to be touched at first point E and then point F. Yeah. Let us mark 2 more points. Let us consider this point to be A and this point to be B. So tell me what will happen. It's an easy question. Okay, try it. Acha, I'll give you one hint. If D is my balance point, so let us mark 2 points. Let us call it as point C. So if D is balanced, what is the meaning of that? This means that potential at C is exactly equal to potential at D, isn't it? Correct? If this is A, then this is also A, this is also A, this is B, and this is also B, isn't it? So from this I'll get one relation that potential at A is more than potential at C is more than potential at B or not. Basically, if it is balanced, that means that no current is going in this. So current is going directly like this way, isn't it? Yes, correct now. So this implies one thing that I can say due to polar, because this is positive terminal and this is negative. So this is also positive and negative. So this means that we can say that this is due to the battery, isn't it? So let's suppose if I say that what will be the direction of current if the jockey is touched at E, what will happen? So you can see that first point is very clear that E is a point where is my E point? E is a point that lies between our 2 points A and D, isn't it? Correct? So if E is a point that lies between A and D, so what will happen? As we can say E, so potential at A is more than potential at E is more than potential at D. So what will happen? And isn't it? This is my correct diagram or not? Now, as you know that if D is a balance point, so D has the same potential at C, isn't it? So this implies that potential at E is also more than potential at C. Are you able to get me or not? Yeah, so let's suppose if I make a connection of galvanometer at point E, word or not? Let's suppose I took the galvanometer and I pointed it at E, word or not? So what will happen? This potential of E is more than potential at C, as we know that potential of E is more than potential of C. So current will start moving in this direction or not? Are you able to get me? So that's what, yeah. So that this is what is simple. That if this is my case, so direction of current in, so direction of current in galvano uh, is, yeah, is from E to C simply. Are you able to get me or not? Now when I consider a point F, let's suppose I consider our point F. So when I connect the galvanometer, so now look over here. Basically, again you can write the equation that E lies between which and which point. Sorry, F. Yeah, F is the point that lies between our D and B, isn't it? Yes. So this implies one case that potential at D is more than potential at F is more than potential at B. So I got the condition that potential at C is more than potential at F, isn't it? Are able to get me? So that means that if this potential is more, so current will start moving in which direction? Current will pick up the direction from C to F if the jockey is touched at point F. Yeah. So direction current in galvanometer is from which side? So which side? From C to F. Are you able to get me or not? Is this clear? Okay, can I move ahead? Okay, let us do one more question. So this is in this question, what you have to do. So the question is simple: find the balanced length L from end A. Yeah, it's a totally different question. Another case. Okay, first case I'm giving it to you. Simple that I have once again same meter bridge experiment kind of question, but in a total different way. This is something which is kind of imaginative question, you can say. Now see that you might get amazed after looking at this. Oh, sorry. So what has happened that I have the meter bridge perfect, but the point is that this is a 60 ohm resistor, this is a 30 ohm resistor, and see this is point A, this is point C, you can say, and this is point B. So A to C, the length is of L meters. Got it? And the resistance is R. This is also L meters and resistance, but resistance is how much? 2R. So question is find this balance length L, which will be possible over here. Do it fast. So tell me which is what will be the correct answer? What is my balance length? So where do you consider that balance length will be there? First you need to understand that. Is it going to be in between it as at point C? Yeah. Is this is going to see the basically the balance length means the point where the jockey will show the galvanometer will show no deflection. So is that point is C over here? Then where will be my balance point? Where the galvanometer will show no deflection. Balance point means what? That where galvanometer shows no deflection. So where is that point going to be? Remember that this is always present at that region where resistance is more. If you don't know the length, so where my resistance is more? This side the resistance is more or not? Yes. So basically what will happen? The balance length will be not at point C, it will be somewhere over here Let's call that point D, which is located at some distance x from point C. Are you able to get me? So then this gap will be how much? L minus x, isn't it? So look over here. As we know, see, basically if I just consider that this is resistance R1 and this is resistance R2. C to B is resistance, means I'm considering A to C as resistance R1 and C to B as resistance how much? R2. So according to our balanced Wheatstone-Bridge principle, what will be equation? 60 into R2. I'm just writing it. I'm just considering it. I'm not writing any equation. Did I have written R and 2R? No. I'm just considering as a equation. So 60 into R2 will be equal to 30 into R1 or not. So question arises that what is this R2 and what is this R1? Because R2 I'm going to only consider of that length which is present in the balance region, isn't it? So how to find it? Tell me. What is R2 and what is R? R1 will have range where to where? From this point. I'll show it. R1 is from here to here, isn't it? Yes, R1 will consider from this end to the balance point or not. And this length will be of what? R2. R1 and R2, if I write the Wheatstone-Bridge equation, that means that I'm considering which part? I'm considering the balance part, isn't it? So this is R1 and this is what? R2. So what is R1 then? So R1 is what? First this from here to here some resistance R. Then whatever is the resistance in this X region, that is my resistance or not? So what will be that? In total length L, the resistance is 2R. So in X length it will be how much? 2R into X by L. That is the resistance in X length, isn't it? What is R2 then? R2 is the resistance which is present in L minus X. So 2R by L into L minus X. So use this equation 60 into R2, which is 2R by L, or I can write it 60 into 2R by L, L minus X is equal to 30 into R plus twice Rx by L. That's going to be my equation, isn't it? So think what is going to be. So I can, this is 3 to the 60. So 4R, this L and L will get cancelled. 4R minus 4Rx by L is equal to R plus twice Rx by L. So this becomes 3R. If I send this, so this is 6Rx by L. How come 4RL? L and L will get cancelled or not? So this becomes X is equal to how much? 3L by 6, which is L by 2. So where is my balance length? At gap of point A. This X I got na, X is equal to L by 2. So total length from A. So therefore, yeah, balance length from point A is how much? 3L by 2. Are you able to get me? How come it will be at C? Uh-huh. More. Yeah. Yeah. Okay. Okay. If you understood this, then I'll ask a little bit difficult Taran on that. Same kind of question. Same question. Find the balanced length from point A. Same question. Not. I'll not change anything. Now you try. R1 and R2. This is 60 ohms only. This is 30 ohms. But there is a twist that from here to here, this gap is of given length, that is 1 meters. I'm writing it to be equal to exactly how much meters? 1 meter. But there is a point, there is a twist in the question that from point A to B, the wire is not of uniform resistivity. The wire has a variable resistivity. And it is given as, let's suppose if I consider at some x distance, the resistivity is given as rho is equal to rho naught x. Then find the balance length from point A. Do it. Find the balanced length from point A. If the resistivity of that meter bridge wire is not uniform, but it's a variable resistivity wire, do it. Yeah. Tell me how to think. Acha, once again the idea is same. Let's suppose if it is balanced over here, then this length will be, this will be some length or not. This length will be L1. And this length means this resistance part is R2, isn't it? That is our concept only now. Wheatstone bridge. Apply Wheatstone bridge principle, Balak. R1, R2. So equation is simple. 60 R2 is 30 R1. This implies 2 R2 is equal to R1. Now think of what is R2, what is R1. Okay, so see the process how to do it. Now imagine, see, if this is my balance length, so it is at some point away, isn't it? Consider this length to be L. So this is point 0, this is length L. And then this resistance is existing between which region to which region? L to 1 meter. So if rho is equal to rho naught x, basically, so I can define for a very small length. Let's suppose I selected a very small length dx. So I can find the resistance for this very small length or not. I call it as dr. So dr will be what? Simply rho dx. Sorry. Resistivity into length divided by area of cross section A. So what I'll get? Rho naught x dx by area A. So what is R1? R1 is simply integrate this 0 to length L, rho naught x dx by area A. So this rho naught by area A is constant, it will come outside. X square by 2, that means it is L square by 2. That is my resistance R1, isn't it? What is the resistance R2 then? L to 1 meter. Rho naught x dx by area A. Do it. Rho naught by A common, x square by 2. So x square, that is L to 1 meter. So that is rho naught by 2A, 1 minus L square. Yes. So if I use the equation twice R2, so twice rho naught by twice A, 1 minus L square is equal to R1 rho naught by twice A L square. So this got cancelled. So what I'm left with? 2 minus 2L square is equal to L square. यही होगा ना? So what I'll be left? 2 is equal to 3L square, or L is equal to root under 2 by 3 meters. That's your answer. Understand how to apply the concept. Understand it. Okay. So these are all the types of questions which can be asked from meter bridge. Are you able to get me or not? And we did all types. So your task is to understand it. How to use the meter bridge, how to consider it. Got it? Now, we are moving to our last experimental setup, and that is called as potentiometer. Question arises that what is this, isn't it? So basically, in simple terms, this is nothing but a device which reads, okay, voltage with current drawn from circuit. Got it? So simply, like, it will read the voltage how much, Like let's suppose if there is a resistor, it will draw some current, and that resistor, if drawing some current, then it will have a voltage drop. So potentiometer is used for measuring that voltage drop. Are you able to get me? So this is, yeah. So this is why it is also called as a. It is also known as ideal voltmeter. Is that clear? So question arises that how this circuit is made. So we have once again a meter bridge kind of thing only, but with a different idea. Okay, 1 minute. This is the representation of our potentiometer. Means in a simple way, there are 2 points A and B, and they are the readers. Here we have different marks. I don't know that what is happening with our potentiometer. Are you able to get me? This is one simple case. This is called as potentiometer box. That once again I have a kind of a length wire, and that there are two terminals which are pointed with a resistive material, and here I can find my potential drop in a very easy way. Are you able to get me? So there are some certain conditions of potentiometer that we need to take this uniform wire of high resistivity and low thermal coefficient. That means alpha. Are you able to get me or not? Basically, these wires, when I take it, this is basically made of two important materials. It is called as manganese, and another one is called as constant tan. Word or not? Constant tan. Wait, constant tan. So you need to consider, yeah, magnete, not magnitude. It's magnete. Magnete is a material. Constant tan is also a material. So from these only I'll create the, yeah, manganese. It's magnete, not manganese. It's manganese. Okay. So these are two different materials from which our potentiometer is potentiometer wire is considered, and where I read our voltage reading. Got it or not? So I'll show you the primary circuit, means how a simple miniature circuit is made to understand about the voltage. So what we have some, let's suppose, instead of resistors, here I have batteries. I have a battery which is connected with a variable resistance source. Okay, and that is connected with a wire. Is this clear? So this is my battery, or this is called as driver cell. क्या बोलते हैं इसे अपन? Got it? And it has internal resistance R. Okay, this is called as potentiometer wire, which is of some length L. Got it? It is a potentiometer wire of length L, and it has a resistance R also. Got it? Yeah. Sorry. So two things are there: battery, variable resistor. I denote it as R small h, potentiometer wire of length L, and it has resistance R. Void or not? So let's suppose if I select 2 points A and B, the current will come along this side, go along this side, goes over here. Got it? So then question arises that what is the value of current? The potential, see, the battery is only providing the potential drop of E. So I is simply I by RH plus internal resistance plus the resistance of the, yeah, got it? So question arises that what is the voltage? I need, see, potentiometer is the way to find the voltage across the current drawn or not. Where is my current drawn? In this wire. So I will try to find the voltage across AB. And that will be simply I into the resistor R, isn't it? So this is what? E into resistor R divided by RH plus R plus R. So this is my condition of voltage in the primary circuit. Are you able to get me? And this is also called as the maximum voltage that can be measured with the help of potentiometer. Is that clear? Now, as you can see that from here to here, if I select different points like A, C, D or something, you will see that the voltage is continuously decreasing, isn't it? So voltage is changing with respect to length or not, and this thing is called as potential gradient. Gradient means anything which varies with respect to length. If I say potential gradient, then I'm defining a bound variation in potential with respect to length. It has a special signature. It is denoted as what? Lambda. क्या चीज denote करती है इसे? Lambda, and it is exactly equal to V by L. Okay. So potential gradient is nothing but it's my voltage per unit length of potentiometer wire. Is this clear? Okay. So what I'm going to do, so basically I told you already. Let us once again have the explanation. Simple explanation is that I want to find how much voltage is drawn through the given resistor, which is imagined like a length of length of potentiometer wire. So I have in the circuit internal resistor, then variable resistor, then the resistor of the potentiometer wire. So current in the circuit is E by this total resistor. So therefore voltage drop across this AB is simply I into my resistor R. Yeah, is this clear? So with the help of this primary circuit only, we have the different uses of potentiometer wire or potentiometer box, correct or not? The first use is in the calculation of EMF of battery. So do you know this? Do you remember it? How do we do it? Any idea? Yeah, so basically Basically, the point is that these all things will remain same. Means whole potential primary circuit is always going to be same. Word or not? Yeah. Set control Z. Oh, shit. 1 minute. I can't decrease it. No. So give the heading calculation of EMF of battery. So primary circuit is same. Word or not? Nothing changed. There is no change in the primary circuit. What we do? Simply we just take, as we know that if we have resistors and all, and I can have a balance length with the help of a galvanometer, isn't it? So what we do? We connect a galvanometer with the another battery. Which battery? See, and then it is connected to this circuit. So you have the primary circuit, then the galvanometer circuit. Okay, and this battery only means this. Remember that the battery of which you want to find the EMF or resistance or EMF that is connected with the galvanometer. Good. So this is, let's suppose, E1 having resistance how much? R1. The galvanometer is connected to that battery whose EMF we want to calculate. So let's suppose this is A, B, I call it as point C, this is D, and this point is called as E. Let's suppose here I am getting a balanced equation, which I am getting balance length or something like that. Okay. So look over here, if this was throwing a current I, so here I'll also get some new current I1. I call it as current how much? I1. Is that clear? And let's suppose that this length, the total length of the potentiometer wire is L. So this length given to us is simply X. Got it? So I have two terminologies. First thing is driving case, means where we define our primary circuit, where we define everything, and the second case is our the circuit in which the potential or the battery which is connected, or that battery is connected, for which I want to find the EMF. Word or not? So let us understand how to do it. So what we have done now. Can you hear me now? Hello, hello. That little bit of network problem. Hello.